Open a new SPSS window. Hope you are able to do the assignment.
Yes.
Okay, open a new SPSS. So we want to import data here to SPSS, but before import data SPSS, we want to start with looking at one sample Ttest. Hope you have a notebook with you always,
Yes.
where you can be able to note some things. So in hypothesis testing, we are interested in rejecting and failing to reject the null hypothesis. So in hypothesis testing, we have types of hypothesis. So you have null hypothesis and we have alternative hypothesis. And then we have types of tests. So we have one-tailed test, we have two-tailed test. So from there, every time we have a problem, we formulate a hypothesis. A claim, we refer it to as a null hypothesis. And then we compare it against the alternative hypothesis. So for example, in this material, in this session, you will be able to learn about one sample t-test. You are going to learn about two sample independent t-tests, and you are also going to learn about two sample dependent t-tests. So we want to start with one sample t-test with the generic data, just simple data here. So before we import data from outside, so suppose we want to maybe, for example, compare a particular data value, a particular mean with the sample mean. For example, we call it hypothesized mean. So what we usually do, for example, let's say you have scores for let's say your class. Your class maybe is of 10 students. So you definitely start with creating a variable. So go to variable window, define a variable, call it score. Define a variable under name, call it score. Fill in those details as you go. Fill in those details up to the end. Fill in those details up to the end for the variable you are creating. So it is score. So it is it's continuous. So you can just fill in because you know how to enter data. So you can just fill in those information. It's a score for students. You have to put a label there. You cannot leave a label blank. How to give a label. There is no value because it is continuous data. So you just go to the measure, you change measure to the appropriate. What do you think is score a measure? It is student score, like marks for the student.
Scale.
Yeah, it's scale. So student marks is scale. So once you have that, you go now to the variable, to the data view. So we have created a variable known as score. So we put there generic numbers for the scores for 10 people.
So I should write like 20.
Yeah, just like that. Faster, we move on. You cannot even take another value in between anyway, no problem.
Mm?
So for your case, I think
Little bit.
the mean score for your students will be around how much? The mean score. The mean. So we will find out that. So let's say that we want to estimate our mean for the class, for this class. Our mean is, let's say we have a hypothesized mean. We want to claim that from your class of 50 students,
Mm-hmm.
the hypothesized mean for your class, we hypothesized mean, that means that assumed mean. We can assume that your class has a mean of, let's say 60, a mean of 60.
Mm-hmm.
So we collect a sample of 10 students, max of 10 students, and then we now want to conduct a one sample. So we want to compare if the mean from these 10 students will be different from 60, the one we assumed, our assumption. So that's what we use one sample t-test to do. Remember, it is just one sample, and then now we are testing it against a hypothesized value. So for you to conduct one sample t-test, so you go to analyze. Once you have your data, the column you want, you go to analyze, and then you can proceed to something like compare means. It was under compare means as well. Yeah, one sample t-test, and then carry your student score variable to the test variable. And then under test value, remember it is 0. Now you will change 0 to 60. I think you're okay. You can just produce the results. We see if it is different. So just click OK. So that's how we perform one sample t-test. We start by computing mean. You see here now, the mean for your data is 64. The mean for those 10 observations is 64. So we are comparing if 64 is different from 60. The hypothesized mean, the one we assumed. You remember?
Yes.
So that is it. So standard deviation, how far away are observations away from the mean is 28. The standard error of the mean is 9.09. So we go to the one sample t-test. And the one sample t-test, you see their test value is equal to 60. That means that is the hypothesized mean. We want to compare it with the mean that we have, which is 64. So we start with the t-test. We are produced with the t-statistic. This is the one we usually get. The one we usually refer to as t-statistic is this 0.440. That is the t-statistic that we usually get in manual calculation. And then df here is the degree of freedom. For the data, we had 10 observations. So for those out of 10 observations, we intend to n minus 1. N minus 1. You get the degree of freedom of those sample. And then we have here two-tailed test. Two-tailed test means what? It means that the null hypothesis is 60 is equal to mu is equal to mu naught, or mu naught is equal to mu. So mu naught is the 60. Mu
Pardon?
naught.
Me not.
Null hypothesis. Mu naught.
Okay.
Mu naught. There's a symbol for mu. Symbol for mu then is equal to mu naught. So mu is equal to mu naught. That means that 64 is equal to 60. That is the null hypothesis. The claim is that 64 is not different from 60, the hypothesized, the test value. The alternative, which is H naught, the alternative, which is usually H1. H naught is for the null hypothesis. H1 is for the alternative. So for the alternative hypothesis, we say that mu naught is not equal to mu, or mu is not equal to mu naught. That means that either mean population mean, which is mu, the 10, the 10 sample mean, which is 64, is either less than or greater than the hypothesized mean, which is 60. You see that?
Um, can you repeat from upper T 0.440? What's T?
T is the T statistic. It is computed in a theoretical, in class theory. It's computed from theory. So here we usually, it's referred to as statistic. Is 0.440. This value is the value that is usually compared with the T table value. The T table value. Yeah. So if you have learned about T table, this is the T statistic that we usually compare with the T critical from the T table. So in this case, once you are provided with the significant value, in this case, it is sig two-tailed value. You don't have to go and check the T table. You just use the value under the sig two-tailed, right?
Yes.
So the T statistic is 0.440. The degree of freedom is 9, which is n minus 1, the number of observations minus 1. And the sig value, which is the p value calculated, is 0.670. That is the p value, 0.670. That is the p value, 0.670 is the p value. And then that value is usually the one that is usually compared with 0.05, the alpha we were talking about in the previous classes, 0.05. So we compare 0.670 and 0.05. So we said if the value here, the sig value, is less than 0.05, we reject the null hypothesis. We said that if the sig value is less than p value, which is 0.05, we reject the null hypothesis. So what was our null hypothesis? The null hypothesis was that the means are equal. 64 is equal to 60. So in this case, we have 0.670, which is greater than 0.05.
Fine.
So that means what?
We
We
failed.
fail to reject the null hypothesis. When we fail to reject the null hypothesis, that means what?
Them.
64 is not different from 60. Statistically different from 60. 64 is not statistically different from 60. So we can still assume that the mean for the class is actually not different from 60. It's not different. It's still in the range. So suppose you do the same and you change your value from 60 to another value like 50, then it will be different. There is some level of significance, some level of significance. So in this case, at 95% confidence level, the confidence interval. Yeah. So we assume that actually the mean difference is not significant. The mean difference is the next value, which is 4. The difference between 60 and 64 is not that significant. So, and the bounds we can have here, we have here the bounds for the lower and the upper interval, the bounds for the mean difference. So the mean difference for the population mean, for example, now the total of 50 students. Now, when we do the average of these 10 people, 10 students together, like in their whole population, 50 students, the mean is supposed to, the mean difference between the population mean for the 50 students and 60, the test value, is supposed to lie also in the range of negative 16.5678 and 24.5678. Is supposed to range in that. Then the difference between the population mean. Remember, the population mean in that case, it will be 50 students. In this case, we took a sample of 10. So when we want to check if actually in which range, in which range will the population mean be? So a population mean has an allowance of the difference between population mean and the test value will be in the range of negative 16.5678 to 24.5678. So that's how we interpret the t-test. And that table is the one that is actually just important in terms of interpretation of t-test.
Mm-hmm.
Yeah, the lower one, you don't have to use it. So it was just added because it was checked during the running of the analysis. So you can repeat producing the same analysis with 50 as your test value.
With, pardon?
With 50, we produce the same result with 50 as the test value.
This one.
Yeah, so here we also see that it is, we still fail to reject the null hypothesis. But for the t-test, we also require that your sample should be enough sample. So we are just using it for learning purposes. But we are going now to import data here for us to run an analysis that we can say we can rely on. Here we only have 10 samples, 10 observations. That sample is very small. So let's import data and try to perform search using a particular data. So I want you to go to File.
Two?
You import data. You import data to Excel. You don't to SPSS. You don't get data from Excel maybe by copying. So go to SPSS. Just go to your SPSS. Just go to your SPSS where you are.
Mm-hmm.
Go to File. Go to Import Data. Go to Excel. Now go to where you downloaded. Go to Downloads. Change from Documents to Downloads.
Yeah.
It's there.
Okay.
Look for the data set that we imported known as exam data. Click on Open. Wait for it. All sheets as Excel file appear to be empty. Or just click OK. Let's see what's happening. Just go to your SPSS. Just wait for it to. How many windows of SPSS do you have open?
1, 2, 3, 4.
Can you close everything and open SPSS blank sheet?
Should I save
You
this
can
one?
save that one is just a demo, so you don't have to save unless you want to. Click on yes. Click on yes. No, save changes, no. Okay, you can just save if you want, but you can just say no on save changes. No. Yeah. Now open your SPSS afresh. SPSS should be there. Yeah. Close that window. Go to files. Now import data from Excel. What's wrong with your SPSS? Just click on OK. Let's wait and see. Yeah, can you close your Excel? Is your Excel open for the
Yeah.
data? Close the Excel. Okay, now repeat the process. What's wrong with you? Alternatively, just open it in the Excel and you copy it. But that is the procedure of importing that data to SPSS. So just copy that data. Click anywhere in your data, Control A.
Yeah.
Copy, Control C.
And then I open my Excel.
And then go to your SPSS. No, you have already copied,
Yes.
so go to your SPSS. Now you can paste there under data view. So what you'll just have to do is to take the first column as variable name. So copy the first column there as variable names. No, copy the first, not first column, first row.
This one.
Just copy that when you paste it in the variable name. Copy one by one. Copy one and paste as a variable name one by one. Copy code, go to you and replace that, yeah. Control A, and then you copy and paste there. Yeah, so copy and the others. But the way of importing data to SPSS is the other method of importation from any other file. Then change the data types. Change the data types to numeric, or yeah. For gender, you will not change it to numeric right now. First of all, go to the data view, and from data view, remember when you check if it can change to numbers, it will not be changing to numbers. So you want to, first of all, give labels to them. When you do the other way around, when the data is already there, it will delete the data the other side. So what you do, you find and replace. So you go to view, go to edit under file, just near file, edit, go down to search, not search, find and replace. Have you selected the column? Selected the column that you want first. So select the column gender. Yeah, now go to edit and then go to, yeah, replace, go to replace down there. Yeah, so you start with giving, if you want 0 to be for male or for female, just do your thing there. As long as you will remember to now, when we change to variable view, you do the same now under values.
Replace all.
Yeah, you replace all. And then you go to next, you change to something else.
Say another number.
No, so we just have male and female. So just close. So you can now delete the first row by right clicking on the other far end, the far end for you to the first row. Delete the first row. The first row, you go to 1. To delete the first row, yeah, you right click and you clear. You don't cut, you have cleared, but no problem. You have to clear, not to cut. Cut means you want to go and paste somewhere else. So you go to your variable view, and under variable view, now change from string to numbers, and then you go to now values to numeric, and then you click OK. Now you go to your values. Now under values there for gender, we are talking about gender. So change there before you forget what was 0 and what was 1. So after doing that, you can change the measurement, the measure. You can change the column to 8, change columns, everything change to 8, so that they are well sizable. Because when you check right now, everything is shapeless. So we need it to be shaped, to be in a particular shape. So let it all of them be 8. So you go to measurement, change numeric data. That one, leave it as nominal. Go from the top. The code is not even supposed to be there because we are not going to use the code data. We're not going to use the got data, but no problem. Just give it a scale. Of course, you know revise is which type. You know exam is which type. You can just check the data, how the data looks like, and then you can give the appropriate measurement.
Anxiety, you can give it ordinal.
Which one?
Anxiety.
Anxiety is a score out of 100, so it's not an ordinal. It's a continuous. Even revise is the number of hours you've revised, so is scale. Number of hours you have revised, and then exam is the total score, and then the other variable is anxiety, is your level of anxiety out of 100. So from there, we want to check, we want to conduct a one sample t-test for the exam score. So first of all, the first thing you should do, you should understand how your data looks like. Of course, you should do descriptive statistics at first, but now because of time, we are not going to do that. You can explore descriptive statistics later at your own free time. You can even do any plots that you can be able to do at your own free time. So first of all, check if gender is okay by converting from numeric to string, just there at the top, down below help, change that. We see if it is working well. Okay, it's working well. Now go to analyze the procedure of producing a one sample t-test. So do the one sample t-test. So we want to compare exam score. So you can just do the way we did for the other exam.
Mm, 70.
Yeah, give a value you think you can give, and then uncheck that. First of all, wait and check the estimate effect size because you're not using that table. So click on OK. So I want you to interpret for us.
The number of mean is 103. The mean, the exam is 56.57. Standard deviation 25.94. The error mean 2.550. Then on the sample test, degree of freedom is 1 or 2, n minus 1, and then sig, which is p-value, is 0.001, and it's less 0.001 is less than 0.05. So
Yes, now
we
what do we
reject,
conclude?
we reject the null hypothesis.
And when we reject the null hypothesis, what do we conclude? What's the conclusion now?
The mean have a difference.
Mean have a difference. So that means that 70 is different from 56.57. So that's how we conduct the one sample t-test. Remember, this is one sample t-test. We have two sample t-tests. Remember, we are only using one sample. That's why it's called one sample t-test. Right? So
Yes.
suppose we want to know if male perform better than female. We conduct something we call two sample independent t-tests. We conduct something we call two sample independent t-test. So we want to test if male perform better than female or female perform better than male. Like in any way, is there any performance in terms of gender that differ? So for us to check that, we follow the same procedure, but now we will be conducting two sample t-test for the independent sample t-test. Go to independent sample t-test. That one is the one we use for that case. Now you will take your test variable as exam and your grouping variable as gender. So in this independent sample t-test, you must have two samples. One sample must be categorical and one sample must be continuous. And the categorical variable, take the gender variable. Take the gender variable. Yes. Maybe you can define group. Because you had specified one and two. So click on define groups down there. Yeah, it's already defined. Okay. Yeah, continue. Okay, so that's it. You click OK. We could have deleted that table down, but no problem. So here you see we have group statistics, like comparing the mean for male, the mean for female. We can see there the mean for male, mean for female. You can see their respective standard deviation. We can see how many are male, how many are female. Then down there we see the independent t-test. Something that has been just added here is the f-test. F-test. Like the F statistic. This is the F statistic. The F statistic is just the one we usually use in ANOVA, in analysis of variance. We usually use it in analysis of variance. So we shall just check that. So F statistic is usually compared with an F table value. So in this case, we don't have the F table value, and it is corresponding. This is just Levin test that is used to check for the equality of variance. So we are not looking at that table, the first F statistic and significance value. We are not checking that. So remember, the analysis we are going to use is the equal variances assumed. We are using the equal variances assumed. And then you will go to straight to t-test. From t-test, look from t-test, T statistic, DF, the way we had in the previous, and then the degrees of not the degree of freedom, the p-value. We are looking at row-wise, not column-wise. So look at the t-test, DF, significant value, row-wise for the first row, equal variances assumed for the first row. So which value do you see there? Is 0.963. We are looking at that, assuming equal variances. And then the value that we see there is 0.963. So what do we conclude here? Because we are testing the null hypothesis that the male and female are their performance, they are equal. Their means are equal. Means for male and female are equal. The alternative is that the means are not equal. So what do we conclude here?
We fail to reject.
Yeah, we fail to reject the null hypothesis. So if we fail to reject the null hypothesis, what does that mean?
The means have no difference.
Yeah, the means have no statistical significance difference. When you check their means, you from their group statistics, you see it is 56.69 and 56.45. So they are not actually that different. The table above, the lower one is not supposed to be predicted, to be interpreted just the way we dropped it in the other cases. So you look at the group statistics at the top, the mean for female is 56, the mean for male is 56 point something. So the difference is not statistically significant, and thus we can be able to conclude that. So this is the two sample independent t-test. You see?
Yes.
And now we have learned about the two sample independent t-test. There is another one type remaining known as two sample dependent t-test. Two sample dependent t-test. So for that case, we don't have its data here. We don't have its kind of data here, but we can put its entry. We can put an entry and test it. So you can just go to your entry, open a new data for entry. So for two sample dependent t-tests, it requires that we are testing same observations twice, because we call them, sometimes we refer it to as paired t-test. For example, pre-test score and post-test score, something like that. For example, someone, let me use the example of students. So for example, we can give an exam to the students before they watch a particular video, and again give them the same exam after watching that video. So we want to know if the performance before watching the video was better than the performance after watching the video. So that's why we use two sample dependent t-test, which we usually use it as paired. You will meet another name known as paired t-test or dependent t-test. For the independent is usually sometimes referred to as unpaired t-test. So for example, we can have their variable known as pre-test score. So go to variable view, then you can have pre score, just call it pre underscore score, because we said you cannot give yeah, you can leave space. Then go to the next variable, call it post underscore score. Yeah, so everything is numeric. Uh, measure is scale. Measure is scale. So you can give the labels maybe if you want pre-test score, something like that. You can just repeat the same, no problem. Pre-test score, post-test score. So suppose we had 10 students. So go to the data view. So suppose we had 10 students. So these 10 students, we give them an exam before going to library. And then after going to library, we give them another exam, which is just the same. Now we want to know if the performance before going to library was better than the performance, and or if there's a difference in the performance, you see, before and after. So for the two dependent sample here, you are testing the same people. Remember, you have the same people, but twice after some time. You see, after undergoing a particular treatment. You see, do you get that?
Yeah.
Yeah. So we want to have an example of 10 students. So just give there some generic performance for pre-test score. So they may be lower than the ones for the post-test score. So just give some values between yeah, that range below 50. Just give any values below 50 in that range. You can give the other values in between. We have 45, we have 48, we have 34, we have, you are just using zero. You're just using flat numbers. Yeah. Yeah. So for example, we give these students a score, and now we want to find out if actually going to library was better than is significant, is important. We usually use this to just test if a particular process was important to do. For example, if it is marketing, those values you can give them better than that value. You can give them above 50. Yeah, so around 50 something is going ahead because it is after undergoing a particular. So we just want to test if to see if it was important going to library or it was important doing advertisement. If it is business, we want to know if advertisement was significant in terms of the number of clients that we get. So maybe we can observe, we can just look at our customer before we maybe build a website. And then after building a website, now we want to know after some time how many customers have increased. And then we check, is there a difference in terms of customers? And then now we can be able to know, yeah, that actually building the website was significant, like advertisement was significant. So it is not only into education. We usually use it even in the medicine, even in business. In medicine, where when we want to, for example, test the immunity of someone before going for a particular treatment, before seeking particular treatment. So maybe we can have pre-surgery score, and then we go to post-surgery score, something like that. So we maybe just do like that, yeah, something like that. Now from there, you have already created your variable. You can proceed and perform two sample dependent t-test, two sample paired t-test by just going to analyze. You don't have to add another variable. This one we said is two sample. Everything is two sample. You cannot have three samples. Now go to the lower one. You see it is now called, not the lower one is proportion. So there is another one in between there. After one way and over, yes. A paired sample t-test, that one. So you see there, paired variables. So they will ask you, what are the paired variables? So take the variable one. Oh, sorry. This is referring to the data, the other data. So close that, close that. Go to our data view. Go to our data view. Then go to analyze. Why is it referring to the data, the other data set? So go to the compare means and stuff like that. Go to paired sample t-test. Yeah. Then now take you have take those two variables there. Yeah. So once we have those two variables there, variable one and variable two, then we can be able to produce the results. So just uncheck that effect estimate. Uncheck that effect estimate. Yeah. Just click on OK. So we can be able to see here the paired t-test. So we can see the mean before the score and the mean after the before the test. The mean before going to library and the mean after going to library. So that means this 25 and 68 are the one we are comparing if they are different. Just the same way we do the other case. So we are not looking at the correlation. So we go and look at the paired sample t-test table. And the unpaired sample t-test table, we just look at the sig value because the other things just the same like in the other case. So when we look at the sig value, we do not the null hypothesis. The null hypothesis is that the mean they are equal. The mean before and the mean after they are equal. That there is no significance. There is no importance of going to library. That's what we are saying. Like there is no any significant impact of going to library on the student performance. You see? So you can use these things to research.
We're looking at
No, we
Nini
are not looking at that. We are looking at the
is
one down. The other one is for correlation. We are not checking for correlation. We are looking at paired sample test.
mhm.
Yeah. So you look at that value. So that value is the one you interpret with relation to the null value and null hypothesis and alternative hypothesis. So what can you say?
We reject.
So we reject the null hypothesis. So what does that mean?
The means have a difference as it
Mean
were.
have a different. What does that mean again? In conclusion, because when you just tell people mean has a difference, people will mean of what? They don't even know that you
The,
tested mean.
the mean of pre-test score and post-test score, they have a difference and there's no need of going to the library.
Are you sure if they have a difference, there is no need for going to library?
Oh, they have, there's a need as in, there's a,
Yeah. So
yeah.
you have said they are different, and again you say there is no need for going to library. Yeah, so there is a need for going to library. That means that going to library was significant. It had an impact on the students' scores. Remember, they were tested before going to library and their performance was 25. After going to library, their mean average is 68. 60 or 68, I don't see clearly there. But yeah, around that value. So that is that is it. That is how we perform t-test, hypothesis testing using t-test. Do you see how it is interesting than calculating in theory?
Mhm.
Yeah, so you need to understand how to perform all these things because these are the things you use in the field, in the market, in the industry. So uh, you will not be asked to calculate the I don't know what using your calculator. Yeah, you will need to produce this and make decision as fast as possible. So having said that, so that was a very nice session. So I don't know why your SPSS, I think your Microsoft Excel has issues and would like to import another data set for us to learn the last thing, which is chi-square. So that when you get this video, you can be able to follow along and then know how we did the interpretation. Now we want to perform the last thing, something we call chi-square. Chi-square. So we want you to get the smoking data here. So try also in file, go to file, we see if the smoking data will be able to come here without copying from the side. I think your Excel it has issues. Open there. Then I think, yeah. 2002 all sheets in
Install
Excel file here. Yeah, so just open it, open the data in Excel and just copy it. So maybe, yeah, just copy it. Open the data in Excel and just copy the data.
So I should open a new limit kwanza.
No, just go to no problem, not unless you need to do that. Yeah, just you have to open because you will need to paste. Yeah.
Mm-hmm.
So you have to get the data. So just go to your SPSS, your Excel file for the smoking, and you copy the data. If you can enable editing there and change everything while still there, it can be better as well. Have you copied? Yes. Okay, paste there. You should enable editing first in your Excel for you to be able to copy. You cannot copy without editing in
Ah,
Excel. So enable editing there at the top. Enable editing. No, there is enable editing just there, the strip, the protected view. Enable editing. Yes. Now copy. Yeah, so once you copy, so this one has gender, male, female, and has smoking habit. So smoking habit, we have non-smokers, we have current smokers, and stuff like that, and stuff like that. And we have three. The second one, we have three. Smoking, we have three. Non-smoker, first smoker, current smoker. While for gender, we have two, male, female. So you start with replacing the way we did in the other data set. So you start with the replacing. You can start with the naming variable. So I'll just keep quiet to see how you do everything to the end until we get data that we can change from male to female numbers 1, 2.
um, can't find the name to replace this. Happened.
Call it smoking. Call that variable smoking. Kindly check your data view. You see, I said what to do first. Undo. Go to undo at the top. There is undo
Where?
and icon. There is undo icon. Yes. Undo that. Click on it again. Click in there. So go to your data view. Go to your data view. Yeah, so what you do first, we say if you get data to SPSS in this format, this procedure of copying and pasting. First of all, change everything to numbers. First of all, change everything to numbers. Just give the variable name. Just go to the variable view and give the variable name. And then first of all, change everything to numbers before. Not there. Go to the variable name. Give the name of the variable for the second variable. Give the name smoking. Then go back to data view. You have to first of all change everything here, replace everything here with the numbers before you change the data type. Before you change the data type. So you have to replace everything. Even gender, you will also have to replace here before you do anything. So we said we have three cases. We have non-smoker, we have first smoker, and we have current smoker. So you can go to find, you can start with if it's find what you can specify there. It is case sensitive, so just know how you type that. Non-smoker, you can give them +0. And remember, it is case sensitive. It is case sensitive. Smoker is capital S. So first you can give them 1, and then current will give them 2. So once you have done that, so define those values there, define the values. So change the type, change the type, change the type, change the type, change the type for your variable type to numeric. Just click OK. No problem. So that's okay. Change the column size back to 8. Has resized to 14. So let's change it to 8. So it is nominal, so it is okay. So you have to do the same for gender. Do the same procedure for gender. You had not defined you've not defined the values. Okay. Continue. Now go back to your data view. Try to change the views. Now everything is okay now. So every SPSS data must look like that. Every SPSS data that is categorical column or data type must look like that. That's something that you should not. And you should know how you can treat your data so that you don't lose your data the way you can lose when you start by what will be the variable b. So you have first of all to find and replace, and then you can change the data. You can change the data. You can change the data type. Is that okay?
Yes.
Now we can proceed to chi-square test. So chi-square, we want to check if there is an association between categorical variables. Chi-square is used, chi-square test of independence. We have three types of squares. You will meet this if you have not met it. You will meet it still in the class, in theory still. We have three types of chi-squares. We have chi-square test of independence, we have chi-square test of goodness of fit, and we have chi-square test of homogeneity. In this case, we are considering chi-square test of independence only. We are using chi-square test of independence stroke chi-square test of association. It's usually also known as chi-square test of association, independence association. So it is usually used when you have two categorical variables. Both your variables must be categorical. So you will plot a contingency table. Here in chi-square, you construct a contingency table, which we usually call cross tabulation, Do you remember in the previous class, we had something like that?
Yes.
Yeah, so you do the same. So we want to do the same on this. I think we did it last class, but we have to do it the same way we did. Yeah. So there, just first of all, go to statistics so that you can include the chi-square test now, the chi-square, check the chi-square, and now you can click on continue, and then now you can click on OK. So at least there now we can be able to see the cases that we have 402 cases in our data, and the missing cases are 9. If I can see pretty well, and that is missing cases are 9. If I can see well.
Yes.
Okay. Let's proceed. Now, when we go to the gender and smoking cross tabulation. So you see, this is what we call the contingency table, where you can be able to plot gender on the rows and on the columns smoking. So you can know how many male are non-smokers, how many male are past smokers, how many male are what? Are
Current.
current smokers, how many female, like that. And then we can be able to know total of male 193, total of female just across the row, you see 209. When you look, total number of non-smokers 297, total number of past smokers 37, total number of current smokers 68, and the total number of the data that was used here for the not non-missing values are the one that are usually plotted on the contingency table. So we have a total of 402. 402. See now this information, we could not see it until we populate the contingency table. And then now further, chi-square will be able to test if there is a relationship between gender and smoking. Like, can we say that male are addicted to smoking than female? Or can we say that female are more addicted to male than, things like that. So we conduct a chi-square test. So you can see the asymptotic significance value, Pearson chi-square under asymptotic significance value. We have a value of 0.205, which we usually compare with
0.05.
0.05. So what can we conclude here?
We failed to reject.
We fail to reject the null hypothesis. The null hypothesis is in chi-square is usually that there is independency. Like there is no association between gender and smoking. there is no association between gender and smoking. That is the null hypothesis. The alternative is that there is an association between gender and smoking. So indeed, we fail to reject the null hypothesis. What does that mean? That means that there is no relationship or association between gender and smoking. That means that if someone smokes, not that because he's female or because he's male. Someone smokes because the someone smokes. Maybe there is another reason for that, which can require further analysis with a lot of data, another data. But on relation to this, someone smokes because someone smokes, not that because he's male or because he's female. This is just a sample data, not that it is actually the true picture of what happens. I don't know, because that is sensitive data that relates to health and requires some privacy and intervention for you to rely on such data or to unveil such data to the public. It requires a large sample size that you can be able to use to estimate. Maybe not unless you focus on a community and then you focus on a village and now find out why are these people smokers? Is it because they are male or because they are female, and things like that. Data is very interesting. Data is very interesting because these are some of the things that you can uncover from data. So that marks the end of our session today. And you can still also explore more on how can you apply chi-square in any other way. Yeah. So that marks the end of our session today. And the assignment you have is to perform independent t-test, two sample independent t-test for anxiety. For anxiety, the data, exam data. You'll be able to explore exam data, two sample t-tests, two sample independent t-test for exam data. The data set known as exam data for anxiety. So between anxiety and gender. So we need to know if male, if anxiety for male was higher than the anxiety for female. That is for the students before the exam or students during the exam. Yeah, that is just what you will explore as part of your assignment. But as part of the project, I will give you a data set for you to practice on chi-square, for you to explore on chi-square. So just note these things as they come. You will have a project that you will work on. So we are likely to have our last session on Friday, but just in case I fail to be available on Friday, we can still have a makeup of the same class on Saturday. I don't know if you are free on Saturday, because on Friday there's somewhere I'll be going, and the environment may not allow me to access my laptop with ease.
I
And I
can
did to, yes.
I can try and be free at 6:15 and join the others.
Even others, I am just doubtful because of this session, because of the whole Friday and the part of Saturday is tricky. Not unless if we can be able to see if we can be able to have the session on Saturday from 6:15. It's tricky on your end. We can I will just see what is possible, and I will let you know. Yeah,
Okay.
if it will not be possible, we can still see what we can do. If we can see what we can do, yeah. If we can even push it to, if the need be, we can push it to Monday same time. But let's see what will be applicable, because I want us to finish this class with you. I don't want to give it to someone else to train you on the remaining part, because I'm the one who know how far we've gone. Yeah, so we will see what is possible on Friday. If not, we can push it on Monday at 8:30 so that we finish it on Monday.
Okay.
Okay. So you have a nice evening. I'll share with you the recording once it is ready.
Good night.